All right, so now we have part two. All right, so in part two, we're going to talk about mass. Right. So what is mass? So mass is kind of a similar concept to weight, but it's a little bit different. All right. So we're going to talk about what is the difference in a little bit. So mass, roughly speaking, you can kind of think of it kind of as weight, but it's actually a little bit different. So what is mass? Mass describes the amount of matter in an object. So the amount of stuff that's there in that object refers to is mass. So for example, let's say you have a piece of styrofoam, right? A piece of styrofoam that is about the size of a brick has less mass in it than an actual brick, right? So in your regular brick that you make a house out of, there's a lot more stuff that's packed into it. There's a lot more atoms and molecules that is packed into that brick. And so therefore it weighs more and it has more mass. So when we talk about measuring mass, usually we use grams, kilograms, anything like that. Anything that kind of ends in grams. That's usually what we measure mass in terms of. So let's take a look at this picture over here on the left. All right. So in this picture we have two scales. On the left scale we have an empty balloon, and on the scale on the right we have a balloon that is filled with air. So what is the difference between them, right? The balloon is the same. The balloon has the same amount of size. The balloon has the same amount of size. There's the same amount of stuff in both of these balloons, right? This balloon over here is deflated, so it doesn't have any air. The one on the right is filled with air. So it looks bigger because it's stretched out, but it's the same amount of stuff. Now, however, when we weigh the two of these balloons, do you notice that on the left, the mass that is recorded is 0.005 grams. The one on the right has 0.010 grams. So which of these numbers is bigger? Well, obviously the one on the right here is bigger. So what is the difference, right? The difference is that this balloon is filled with air. And so you can see that the air has mass, right? Because if the air inside did not have mass, then these two balloons should weigh the same. So that proves that the air around us has mass. That you can actually take the air around us and actually weigh it on a scale and figure out how much air there is. Now, of course, it's not easy, right? I mean, if we put down a scale, it's going to be very difficult for us to, weigh the amount of air, right? That's why you have to use some kind of technique like this, like take the air, put it inside of a balloon, and then weigh it, right? It's difficult to just weigh the air directly. Over here on the right, we just have examples of all kinds of different scales, all right? So we have scales that maybe people place in the bathroom to weigh themselves. We have scales at the cash register. We have this old school balance that you see over here. Maybe you have a luggage scale. Maybe before you go to the airport, maybe some of you guys weigh your luggage to make sure that the luggage is less than 50 pounds, something like that. All right. So there's all different kinds of scales. Now, what is the difference between mass and weight? We kind of use these terms a little bit interchangeably, but there is a difference between mass and weight. So what is weight? Weight is not the amount of stuff that's in an object. All right? That's what mass is. So what is weight? If you weigh yourself on a scale and you say, oh, I'm 100 pounds, 120 pounds, whatever it is, you say weight is a measure of the gravitational force on an object. So what is happening, right? What is happening is that when a person is on a planet, the planet has gravity, right? That's why we stay stuck to the surface. So weight is a measurement of how strongly that planet or that moon or that star is pulling on you or on someone else. So if we take a look at this picture, right, we can see two people, right? One of these people is standing on the planet Earth. Okay, so planet Earth is a regular planet. Okay, now over here on the right, we see another person standing on the moon. Now the moon we know is smaller than the Earth. All right, so one person is standing on the Earth, the other person is standing on the moon. All right, now what is the difference in terms of their mass? In terms of their mass, there's no difference. In terms of their mass, the amount of stuff that's in both of these people, they both have a mass of 50 kilograms, right? Remember we said grams, kilograms, that's how we measure mass. So both of them have a mass of 50 kilograms. There's no difference there, okay? However, their weight is going to be much different. So this person here on the left is going to be pulled much more strongly by the earth because the earth is a lot bigger. So this person is going to have a weight of 110 pounds. Okay. Now, apart from pounds, we also can measure in this thing called newtons. Do you see this N over here? All right. So you can measure in either pounds or newtons. So over here on the left, 110 pounds or 490 newtons. But this person on the moon, right, is not being pulled as strongly. So they're going to weigh a lot less. So their weight is a lot less, like let's say like 18 pounds, it says here, or 82 newtons, right? So you can notice that this person over here is going to weigh less. However, they both will have the same amount of kilograms of mass. So their weight will be different, but their mass is the same. Now, how do we usually measure mass? Well, there's all different kinds of scales that we can use. So in the class, we use the triple beam balance, okay? So the triple beam balance measures your mass. This scale is used to measure weight, all right? So some of you guys have seen a scale like this. We've used scales like this before. So when you put some kind of object down here, it basically pulls down because it's being pulled down by gravity. And so on the scale, you can you can read like how much force is being exerted. So that gives you the weight.